So we're going to continue on talking about Chapter 3, Descriptive Statistics. And we just got done talking about ways to measure the center or to describe the center of a data set. Now we want to look further at ways we talk about the variation of the data. Or you could even use it to talk about the spread of your data. Numbers that measure spread. Now, if you look here on this graphic or this image that I have here, I have two different data sets that are one on the top, one on the bottom here. And if you actually took the points in these and looked at the measures of center, they actually have the same mean and the same median for both. But what is different about the two data sets? And you can obviously tell they're not the same data set, right? Well, what's different about them, or what stands out about them, is the top one is kind of more spread out, and the bottom one is kind of more clustered. So what's different about them is their variance, how they vary amongst each other. So their variance is what is different about those. And that's actually what we want to try to measure or capture in this section of the notes. Now, there are a few ways we talk about the spread, or easy ways we measure the spread. And one of the ways is the range itself. It's kind of a generic, easy way to get an idea about the spread. And you can see the range just calculated by just taking the distance, finding the distance between the largest and smallest values in your data set. So you take your max data value and subtract your minimum data value. Now, it is a very easy calculation to do, but it is not going to be as accurate or as good a representative of the spread as we want, because if you think about it, it is going to be a measurement that's very sensitive to extreme values or to outliers. So very, very sensitive to extreme values. So that's going to make it not as useful for us as probably some other measures of variance, such as you see below here, our next one, standard deviation. Okay. Now, standard deviation, I don't recommend doing it by hand at all, honestly. It is a very tedious calculation, although I do want to look at the formula. And if you do MyLabs Help Me Solve This, they'll oftentimes walk you through the formula method. Now, if you have a large data set, it is so tedious to do the formula method. I mean, if it's a small data set, like 5 values or less, not really that bad, you could do it. It still takes a while. But yeah, it is not an easy formula to do. Now, I want to show you real quick and just kind of like draw you into some aspects of the formula, because we want to talk about what exactly standard deviation is. And like to show you this, so the formula for it, it looks awful, but there's like a square root, and we'll talk about why that's there maybe in a second. But you actually take the distance each value is from the mean. So you're looking at the mean, and each data value, that's x right there. So you want to look at the distance. Now, the reason the square root is there is because we want the distance to be positive. So if you have a value that's less than the average, when you subtract the average from it, you're going to have a negative value. So what we do is we square each of those distances, and then the square root is what undoes that. But we want to take all those distances and add them up, and then basically we divide by how many there are right there. So it's kind of like you're taking an average distance. Now, there is one little thing about this formula that's there. We do n-1. It's a degree of freedom thing because your average is fixed, but you don't have to worry about the formula really that much. But what you're looking at basically is each value's distance from the mean, so x minus x bar, and then we're basically summing all those distances up and then dividing by how many there are, essentially, is what we're doing. So standard deviation is an average, basically distance or average deviation of values from or about the mean. Okay, so it's an average deviation of values from the mean. Now, on the calculator, I did say you don't want to hand calculate these things, because what's more important to us is figuring out how do we interpret the standard deviation, which we'll get into. But on the calculator, you're going to use the 1-bar stats function that we use to find mean and median, And you're going to see it right here on the calculator screen when you pull up one bar stats. It's the S with the X beside it. That is your sample standard deviation right there. Okay. Now there is one third way we talk about spread, and that is the variance. Is that, spread or variation of values. There's actually a term, a parameter called, or a statistic called variance. So basically what you do with it is you take your standard deviation and you square it right there. And one thing I will comment about when you are squaring your standard deviation is you do need to make sure you do the unrounded version of the standard deviation when you square it. So, just be aware that if you get something off on my labs, it's probably because you rounded your standard deviation and then squared it. You have to do the unrounded version. So, like in this example up here, I would have to do that whole decimal, like all the decimal numbers behind that, whatever that digit is, like the 0.13200159. You'd want to square all of that, not just, like whatever to the 1-3. You want to go as far as you could on that right there. When you look at population parameters, so sample parameters, when you're looking at the sample versions, sample standard deviation, that's the S. And if you're looking at the calculator, it's S with the X beside it. And then sample variance, that's the one, that's S squared or SX squared right there. Well, what about the population versions? Now, you never will know these, but in later chapters, we do talk about how do we use the sample versions to learn about the population versions. And you'll sometimes see, even on the calculator screen, these estimates for the population ones, but the population standard deviation is the Greek sigma. It's kind of like a circle with a little hat on it. And then for the variance, when you want to talk about population variance, that's going to be the little circle with the hat on it, squared. So those are going to be your population parameters. And what we want to do is we want to take this data set that are here in this example below. We have 5 students where they measured, how long they think it takes to guess that a minute has passed right there. Okay. Well, what we're going to do here is take these values and find range, standard deviation, and variance. Now for range, it's not going to be that difficult to do range because just remember that's the distance from your maximum and your minimum data values right there. So your maximum data value, that's the 68 second. These are seconds. And then your minimum data value, that's for the 53 seconds right there. And then once we subtract those, we'll end up getting the 15 seconds as our range. Now, standard deviation and variance. I highly recommend using the calculator to do both of these right here. So what I'm going to do is I'm going to go into a list and actually enter in all of those values. So stat, edit, and then I want to enter in my values. 54. And then always double check them if you can. Now, once you get those entered, to find the standard deviation, you want to use one of our stats. So you'll hit stat. You'll go over to where it says calculate. So right arrow once. At the very top, it says one of our stats right there. And most of you are going to see like frequency. You're going to see a little different than I have it. But I just want to do one of our stats on this one. So it'll pull up like that. Most of y'all are probably using the stat wizard. Let me go down here and turn that back on right quick. So it looks like most of y'all's calculators here. Stat wizards on. Okay. But anyway, when you go to stat, calculate, you're going to see it look like this right here. You want to make sure your list is list 1. There's no frequency list, so just leave that blank, and then you hit calculate. And then you'll see on the screen the standard deviation is a 6.58 number right there. So standard deviation. That's going to be 6. Let's just do one decimal place, so 6.6 seconds up there. And that came from that one bar stats. So one bar stats, it's the S with the X beside it when you pull it up. Okay. Now, last is variance, and if you look back to how we talked about how you get variance, what you're going to do is take your standard deviation and square it. So you square your standard deviation, okay? Square standard deviation. But you got to remember, it's got to be the long, unrounded version of standard deviation. If you round standard deviation, you are not going to get the exact right answer. Yours will be kind of close, but it's going to be off enough that you won't be able to get it right. So I'm going to take the unrounded version of standard deviation and then square that. Okay, you can go even more decimal places if your calculator shows you more decimal places. So I'm going to go to the home screen. I just cleared off my stuff right there, but if you ever need to get back to the home screen, like let's say you're in list 1, list 2, this stuff right here, just hit second and then mode and it'll take you back to the home screen. But what I want to do is do 6.580273555. Now I want to hit the little X2 button, the little square button, and it'll pop up a little 2 above it right here, and then you hit enter, and we see we get 43.29 repeating. If you do one decimal place, it's going to be 43.3, and it's interesting about the units for variance. So variance actually is not our go-to way we talk about, spread or variance of your data, because of the units of, variance. If you think about it, when you square standard deviation is in seconds, okay, right here. Well, when you square that, you actually get seconds squared, and a lot of times that is not as meaningful to interpret as, like the standard deviation units, which is the same as your data. So because of that, for the most part, our go-to for standard deviation is, or our go-to for spread is going to be standard deviation when you're working problems.